Yeah, good evening, friends. Welcome to the domain analytics session. So we are going forward with energy and resources analytics. Today's topic is CRISP ML, or we also call this project management methodology. Okay. So first of all, if you are a data scientist in energy and resource analytics, or an analyst even in energy and resources analytics, you will have to work on projects. Okay. So knowledge about how to manage a project and all will be a major requirement. Now, what steps to follow so that we will have a successful, project? What steps should we follow? So let us learn about that. Okay. So here we'll be learning about different stages of analytics. Then we'll also be learning about the CRISP ML methodology. Okay, what it is all about. Then we'll be learning about inferential statistics, unsupervised and supervised learning, data split, various error functions, what is overfitting, what is underfitting. Okay, we'll see all of this. Okay. So let's start our session. So first of all, we'll know about the various stages of analytics. Okay. So as an analyst or as a data scientist, you'll have to go through all these stages. Okay. Analyst might not go till here, but halfway they will have to come. Okay. So let us learn what are these methods. Okay. So first of all, we are having descriptive statistics. Okay. So this asks the question, what has happened? What has happened till date? Till today, you can say. Okay. What has happened till today? So in this stage, what we do, we take the historical data till today. Okay. And we try to make sense out of it. What has happened till today? Okay. So in descriptive statistics, we will do EDA. Okay, exploratory data analysis. Okay, and various other some pre-processing techniques which will also we'll do here. Here, just visualization will create and try to find more about the data. Okay, and by finding this out, we can answer the question, what has happened till today? Okay, then coming up to the next stage of analytics, that is diagnostic. Okay, so here we will try to diagnose. We'll try to diagnose whatever has happened till date, why it has happened. Okay, here we'll do diagnosis on why it has happened. So if it is a good thing, then we want to repeat it. If it is not a good thing, we want to avoid it. So for both the reason, we want to know the reason for happening of that event, why it has happened. Okay, for both the reason, for positive as well as negative reasons, we want to know the reason behind this happening of this event. Okay, once we know the reason, okay, we according to it is good or bad, we'll try to repeat it or avoid it. Okay, so here we do we diagnose, also we take preventive measures. Okay, now up to this, okay, a data analyst can perform these jobs. Data analyst. Now comes the hard part, predictive analytics. So based on this data which we saw, okay, based on this analysis, next we'll do some kind of predictive analytics. Here we will make predictions about future based on the historical data. Predictions. So here we can say the question to be asked is what is likely to happen? What is likely to happen? Okay, based on this data, what is likely to happen? So here we are trying to find or predict what the future will be like. Okay, based on past data, what will the future be like? Now, based on the answer to this question, what is likely going to happen? Okay. Now, if that future is good, suppose. Okay. So we might also try to improve further. Okay. Whatever is happening, we might also want to improve it further. If it is not good, it is bad, suppose. Okay. So we are seeing that foreclosure in the future of the company. So how to now avoid that? Okay. So what should we do to do this? Is the fourth step, which is prescriptive. Okay. So we'll prescribe here the solution to these issues. Okay. So basically, this is a recommendation zone. Here in the fourth step, we will try to recommend, okay, recommend for improvement of the company. So these are the 4 stages of analytics. Okay, so this is generally performed by a data scientist. Now, this data scientist should also have the knowledge about this analysis. Okay, it is not that just this much is the work of a data scientist. Data scientist should be knowledgeable about the whole thing, whole 4 stages of analytics. Okay, yeah, but data scientist will do these jobs. Now, this CRISP MLQ, or it is also known as Cross Industry Standard Process for Machine Learning with Quality Assurance. Cross Industry Standard Process for Machine Learning with Quality Assurance. Okay. So this CRISP MLQ is nothing but a project management methodology or stepwise project management. How to manage a project stepwise, it has been given. Okay, so let us go through all the steps and let us try and explain this. Now, CRISP MLQ, first of all, is a project management methodology. So here it is required to be handled if we are having a project. Okay, so if you are having a project, So this project will have a statement, okay, problem statement. Based on this problem statement, okay, you'll be required to form a solution or use your, prowess on coding and all, and find a solution to this. Now this, suppose we are having a business understanding as well as data understanding. So this is a requirement, okay. So whenever you are trying to work on a project, first of all, you should understand that business. Unless and until you understand that business, okay, it will be very hard to do a project on that. So first of all, business understanding is very important. Okay. So as you are given the project, first thing you should do is understand about the business. Okay. Understand about the business. Now, how to understand about this business? It is not that easy to understand a business. So what we can do, we can ask help from SME. SME is subject matter expert. Okay. So a subject matter expert is someone who has, knowledge about businesses and data, okay, about this project. This person has all the knowledge. So any questions if you are wanting to ask, this is the person you should ask. Okay. Subject matter expert. Once the subject matter expert, you are asking him, you are getting to know about the business. Okay. So now you have understood the business. Next is data. Okay. So as you are working on a project from their company, maybe data is directly available. Okay. Maybe they are having a, CRM from which data is directly available. Okay. So we can directly download the data from a CRM and start working on it. But suppose if this is not the case, okay, data is not directly available. So next we'll have to do data collection. So from various databases of the company and all, we'll have to collect them. So when collecting this data, it has come from various databases. So not all the data will be in same format. So we somehow need to now convert all this data, okay, into a same format data. Okay. Once this is done, our data is now ready and we can work on this. Suppose data collection, we are having to collect from primary source. Okay. So means we can conduct survey to collect the data. Now this survey and all will cost you money as well as time. Okay. So it is not a cheap process, okay, of data collection. It will cost you money and time. So this is how we collect this data. Now this data, again, the thing which we are talking about, this is the main source of everything. Analysis is done on this. So now this data has data types. So we need to also look out for that. So if we just speak broadly, it can be divided into two types. One is continuous data. Another is discrete. Now this continuous and discrete among itself can be divided into 4 levels of measurement. That is nominal data. Nominal data are those data which don't have any ranking. So we can say they are of all same ranks. Like if we can consider this color data, color red, color green, color blue. So you might have, subjective perspective on this data, but analytically, these are all same data points. Okay. Red, green, blue are same data point, means they are having same level or same rank. Red is having the same rank as green. Green is having the same rank as blue, like this. Okay. So nominal data, they don't have ranking. Then we have ordinal data. Ordinal data. So these two are discrete data types. Ordinal data now has ranking. So like we have designation. Okay. Designation in a company. So it is having ranking. Next is interval data. Interval data are generally data which can be represented using intervals like temperature. Okay. But property of interval data is they do not have an absolute 0 point. Absolute 0 is not available. Like temperature, we cannot say 0 degree temperature is the absolute temperature. Okay, 0 degree centigrade is not the absolute temperature, because we are having -10, -50 degrees centigrade. Okay, so this is not the absolute temperature. Absolute temperature means the temperature starts from that point. Next is ratio data. Okay, it is the most preferred data because most of the analytical processes can be directly done on this data. And this data has absolute 0 also. It has ranking also. It has ordering also. It has differencing also. Okay, all the properties of statistical analysis. All the statistical analysis can be done on the ratio data. Okay, so this was something about the data. Now data, we can also, segregate this data into multiple other means categories, but this is what we are sticking to. Okay, we can take this data as a structured data, unstructured data, semi-structured data. Okay, there are multiple things by which we can segregate this data. Okay, so data understanding is done. Business understanding is done. So let us go to the next stage. It is data preparation. So now we have collected the data. Okay, so from this raw form, we have to convert this data into a form which can be directly applied on a machine learning algorithm. Okay, ML algorithm. So that needs to be done in the second step. So after collection of all data, converting it into a format which can be directly used by a machine learning model. So this is data preparation. There are many steps. We are not going deep into that. Okay. Once this is done, okay, this data preparation we will be seeing tomorrow in deep. ED and data pre-processing is our topic for tomorrow. We'll see this. Pre-processing. Okay, so it is data preparation. Similarly, we are having model building and tuning, model tuning and model building. Okay, so once data has been prepared, next method we'll follow is we'll build a model. Now this model building, okay, it can be done on multiple models, not just one, multiple models. On multiple models we will build and try to find all the performances of all the models. Okay, once this is done, next we will evaluate the model. So we will compare the performance of all the model, but this performance should be measured using a same criteria. So if we are measuring accuracy, we'll have to measure accuracy for all the models. If we are measuring error, we'll have to measure error for all the data sets. Okay, like that. Okay, once this is done, model building means finding the best model, model evaluation. Once this is done, okay, next step is to deploy the model. Deployment can be either done on mobile or as a web app. Okay, web app means a website app published on a website. Okay, mobile means we'll just make an app which can be used, which can be downloaded from Android store and used. Okay, so deployment. will deploy here on a website or a mobile app. So the thing is deployment converting our ML algorithm, okay, ML model which we have built to an app will have to do this. Okay, so this can be done by pickling this file and using it by using a Flask model, or Streamlit also you can use. So using this, we'll create an app, then we'll then we can deploy it either in Heroku or in cloud, wherever we wish. Okay, so now we are done with this. So let us learn about data mining. Okay, next step, data mining. So in data mining, okay, there are majorly two methods. Actually, there are three methods, but majorly we are discussing about these two because that is a higher end concept, the third model. So let me just write it here also. So first model is unsupervised learning model. Unsupervised learning model. This is supervised learning model. Third one is known as reinforcement learning model. So unsupervised learning model, they are known as unsupervised because there is no training phase. Training phase, no training phase. Supervised, there is a training phase obviously. So hence the name supervised. In reinforcement, this is totally different kind of model in which we place a learner, okay, in an environment and we just watch what it does. Okay, in this environment, how it reacts to the environment, and if it performs a task which you can say we want it to perform, we can reward them. Okay, this is known as a positive reinforcement learning model. Positive reinforcement model. Okay, or what you can do, we can punish it whenever it doesn't do a task which it is intended to do. So it depends on model to model whether to apply positive or negative reinforcement. Okay, so yeah, so we are looking at this unsupervised, supervised. So here no training phase, supervised we are having a training phase here. Here the output is unknown, or why we call it is not known. Okay, now in this model, supervised model, y is known. Okay, here y is known. So here we try to find the relation between x and y. Okay, how are they related? So basically, if we represent them with the basic line equation, y is equals to suppose beta 0 plus beta 1 x plus error. Okay, so here we are trying to find the relation between x and y, and this relation is represented by the values of beta 0 and beta 1. So if we can find the value of beta 0 and beta 1, we will be able to find y for different values of x. So this is what we are trying to find in supervised model. In unsupervised model, we are just having a data set. From this, we are having some data. So measuring the similarity between the data, we try to cluster them together, group them together. Okay, so this is unsupervised learning and supervised we discussed just now. So in unsupervised learning, as I was telling, there will be a historical data based on which we'll apply some machine learning model to directly find the rules and patterns. Now these rules and patterns can be directly used to predict on a new data as well. Now this new data, just keep in mind, should be similar to our historical data. Otherwise, correct prediction will not be coming out. Okay. Okay. Let's go to the next model, that is supervised learning model. Okay. So here I told you we are having a training phase here. So you can see here also we are applying this whole into a historical data. Now from this historical data, we'll have to first of all split our data into two parts, that is training and testing or validation, you can say. Okay. This split is done by SRS, simple random sampling method. Okay. So here we are having a training. So we are having a trained data set and a validation data set. On this trained data set, we will apply machine learning model to find the mathematical equation which we just told you. Okay. So this beta 0 and beta 1 values we try to find here. Once this is done, we'll test the model on this validation data set. Okay. So this validation data set is used to do hyperparameter tuning or choose the correct value for parameters, hyperparameter tuning. Okay, once this tuned hyperparameters are, we are finding this, okay, and we are getting a good prediction. We'll again add these two values and make a final model on this, and then whatever tuned model we have got here, that tuned model again will train the whole data on this tuned model. And once this is done, our model is ready. Okay. Now on new data, we can also predict the outcome. If it was really working really good on training, it will also work good in here. So it will be like input, then put, then output. Okay. Okay, so we are talking about data split. So let us see this a little bit closer. Okay. So our data, okay, we are having a data set. It is split into three parts. Suppose 70% to training, 20% to validation, 10% to testing. Suppose this is the case. Okay. So on the 70% of the data, we will train using a using a ML model. We'll train this. We'll build a model. Okay. Then we'll test on a validation set. Suppose this validation is not happening now. Okay. So whatever you can say this model is built. Okay. It is not working good with this validation data set. So we'll do some hyperparameter tuning and all to correct this. Okay. So after hyperparameter tuning, if it is working now, we'll finalize this model. We'll add these two. Okay. Work on the whole data again. And once that is done, that is the final model we have prepared. We can directly do the testing on test data. Okay. Which no one has seen till now. Okay. Otherwise, if tuning is what we are not getting for a model, sometimes what happens, the model is too simple for a data. So when the model is too simple, we'll get a problem known as underfitting. In that case, we'll not get good result even on the training data. So when this validation, once validation is happening correctly, we can go for testing phase. Okay. And whatever results we are getting in this testing phase, okay, well, maybe it may be prediction and or error. Whatever we are getting, these are known as generalized or generalization. Okay, generalization error or generalization prediction. Okay, so this is how we split the data and work on the data to get a correct prediction. So you need to follow the whole method if you want to, you know, do more amount of time in less. Sorry, do more amount of work in less amount of time. Okay, let's see the next one. So next is evaluation metrics. Okay, how to evaluate your model? Evaluation. How should we evaluate our model? So to evaluate a model, we are having again two classes, which we already saw. One is classification, one is regression. Classification, we are having categorical data. Regression, we are having continuous data. Let us write here a discrete and continuous data. If our data is discrete, means if it is a class problem, okay, we can use this method, confusion matrix. Confusion matrix now in itself is not an evaluation metric, but it helps many other evaluation metric to be calculated by its values. Okay, so let us see this first one, which is for classification model. Okay, this is for classification model. Let's understand. Now, for this classification model, we will first have to build a 2 into 2 matrix, which is also known as confusion matrix. Okay, we'll build this confusion matrix. So this will be a 2 into 2 matrix. Here we will be having, suppose here we are having predicted value. Here we are having actual value. Now predicted value, suppose we are having yes, no. Here also yes, no. So wherever we are finding two yeses, okay, we'll get some value. Yes and no, we'll get some value, this value, this value. Okay. So these four value we have got. Now we see that this is yes, this is also yes, means for yes, we are also getting yes here. For actual yes, predicted yes is also there. So whatever this value is, okay, it is it is having both yes. Similarly, both no also we are having a value. So these two values are whichever way we have captured this gives us correct value. Okay. So once we have got this, we can find accuracy, which takes all the true values divided by whole means all the values. We can also find error, which is all the false, positive, false, negative, false values divided by total. Okay. And accuracy should be greater than a percentage of majority class. Okay. So when we are having a categorical data, we can work with this confusion matrix. We'll create this 2 into 2 matrix. Based on the criteria, we'll try to fill it up, and based on that, we'll try to, get the result or evaluate the model. Okay. Now there are various other error functions like precision, okay, sensitivity, specificity. Sensitivity also known as recall. Okay, specificity, false positive rate, false F1 ratio, many other things are there. Okay. So these are all again evaluation metrics for a classification problem. Only in classification problem we can use this. Now, if so, we saw if our data is uh, discrete data, not a continuous data, then what to do we saw. But what if it is a continuous data? Then how to what to do to control this? Let's see. Okay, so error function. If we are having a continuous, why is continuous? Okay, if we are having a continuous output, we will be using these values. Okay, mean error is this one. Okay, it is mean error we cannot use directly because we can see if we are having a data like this and if you are finding mean error, it comes out to be 0 even if we are having high or low values. Okay, still it is coming 0 for both. So can we make a comparison that this and this are equal because both are losses and both have a mean error 0? Okay, because we can see here the error is here is it is small, here it is large, so we cannot assess this error, this magnitude of error, so we generally don't use. Okay, now this error term can be calculated multiple ways. We can use mean error, we can use mean absolute error, mean absolute deviation. We can also use MSE, mean squared error. We can also find it using RMSE, rate mean squared error. We can also find it using MP, mean percentage error, and MAP, mean absolute percentage error. Okay, and we already talked about this. Accuracy plus error is equals to 1. If we add both accuracy and error, because these are two sides of a coin, we can say. So if we are having greater accuracy, error will be less. If you are having greater error, accuracy will be less. So these are some of the functions which we can use, to evaluate a error function in regression problem. Okay, now model evaluation and tuning. Okay, so model evaluation we saw. If we are having, suppose a classification problem. So let us see this classification problem. Okay, this is so we are having something called as underfitting. We are having something called as overfitting. Okay, underfitting is the condition when we are having a very good model. Okay, sorry, when we are having very good, a very simple model and a very complex data. Very simple model, okay, but we are having the data complex. Very simple model, data is complex. In this case, what happens? This model is not able to get the intricacies of this data. So here you can see, this is a very simple model, a straight line model we are choosing here, which is generally from a simple linear regression model. Okay. So this, by this we can see many data points are not captured. Okay. So that means data is complex for this data boundary or this boundary which we made to capture. Okay. So we can do this using a non-linear equation like this. If we do, we can capture most of the data with some noise. Okay. So this is good actually. Now we are having a third thing here. We can see here we are having the data points are being exactly measured. So is this better? So this is happening because, okay, model complexity is very large. Model is having higher complexity. Model is of higher complexity, and but the train or the training of the data model is of higher complexity, but yeah, data is very simple. So what happens here? Here the problem is overfitting. It causes overfitting problem. Okay, so these are the three models. So this one is for classification, same thing here for regression as well. So regression also you can see this is the sine curve. We are trying to generalize this using a straight line curve, which will never happen. Okay, now this it is a perfectly trained model, you can see. Now this is overfitting because we are trying to train on every part of the given data. Okay, so these are some of the means examples of overfitting and underfitting issues. Okay, overfitting is also known as variance. Underfitting is also known as bias. Okay, now how to choose this training, testing, and validation set? Okay, so we should split randomly. First of all, we should take, okay, we can take 60% into training, 20 to validation, 20 to testing. This can be done, or 80-20 we can do between training and test. Okay, also the largest test set should be able to estimate future error as accurately as possible. Okay, and large training set means we will have better estimates, but how large should a training set be? Okay, so as large as possible is a good answer, because if it is very large, it becomes a big data problem again. Okay, now let us talk a little bit about this these problems: underfitting, overfitting. So overfitting is a problem. It is said to occur when a statistical model, okay, a statistical model is said to be overfitted when we train it with lots of data. When the model gets trained with so much data, what it does, it starts learning from the noise as well, okay, and incorrect data entries as well, okay, in the data set. Then the model does not or it cannot categorize the data correctly because of too many details, okay, because it has integrated, means gotten inside this data. Okay, so the generalization, when it does, it will do something like this. So if data is present here, if we had done a simple linear, not linear, simple curved line equation, we could have gotten this. Okay, but because we had done like this point will be, categorized outside of this data or this category. Okay, so you can say overfitting is an issue when we are having high complexity of model. When you are having high complexity of model, Underfitting is when we are having high complexity of the data. Here, complexity is higher of the data. Okay, here the data is complex, here the model is complex. Okay, now let us talk about this project management in the field of analytics. Okay, project management in the field of, suppose, energy analytics. Now this energy analytics, or suppose we are taking a energy supply project. Energy supply project. Okay. Now this energy supply, management of this energy supply project, okay, it can be very complicated. Okay, it will depend on the energy analytics. Okay, this project will depend on energy analytics. Now this energy analytics does require accurate information, accurate, or we can say relevant also, energy information. Okay, if we are getting this accurate and relevant information, okay, we can do analysis on this, and using this analysis, okay, we can increase the efficiency. We can increase the efficiency of the you can say energy production. It may be, you know, renewable or non-renewable even sources of energy. Okay, but we require this energy analytics, and if this energy analytics is a robust model, means anything you throw at it, it will be able to, you know, work around this. If it is a very robust model. Okay, these companies, suppose public enterprise or a private enterprise, public or a private enterprise, okay, they can make, using this analytics, they can make informed decisions. Okay, they can make informed decisions which might be very helpful for to them in terms of money and time savings, money and time. Also it will mean a better performance. Okay, and also it may be providing you environment benefits. As we know, energy is a you know, as a company which produces a large amount of pollution. Okay, generally if we are talking about thermal, okay, thermal or nuclear, large amount of wastes are produced here, which affects the environment. Okay, not only that, pollution also is caused if you are using thermal. Okay, so we need to consider all these things, okay, when we are building a energy management tool. Okay, These all things should be kept under view when we are creating this app. Okay, so this app which we built, okay, if we are going to build an app, okay, we should make sure that it should, you know, not only give you energy information about energy, okay, that is its prime work. So it should give you, but it should also provide, you know, real-time information on energy whenever require real-time information. Okay, also these are required to, you know, monitor and maintain and monitor carbon compliance. Okay, so all throughout the world there is a carbon compliance which every industry should follow. Okay, if any industry is found not to be following this, they may get banned. Okay, and using this we can also, you know, segregate or isolate, you can say, isolate some poorly performing energy systems. Okay, we are creating energy systems so that our machines or our industries will get more efficient. But if they are only not working properly, okay, if they are performing poorly, okay, so it is not good. We have to isolate these systems, okay, and using all this we can deliver a measurable you can say return on the investment. Okay, a measurable return on the investment can be, you know, we can get back using these upgrades. So we should make some upgrades to, you know, rectify these issues. Yeah, friends, so today we learned about the management methodology, how to manage a project. If you're getting a project, what to do. We also learned about business, how to, means what should we learn about business, data, okay, then converting this data into raw from raw form to standard form. Okay, this is done using EDA and pre-processing methods, which we'll be seeing tomorrow. Also, we learned about data mining methods. These data mining methods will ultimately lead to, again, model evaluation. We'll have to evaluate the model. Once this is done, model is evaluated, okay, we will do model deployment. Once this is done, last step is monitoring maintenance. So this also, after deployment, we need to keep an eye on the model so that we, you know, see that it works properly. Okay, if any update is needed, we should update again. Okay, friends, so this was all for our CRISP ML methodology, CRISP MLQ. Okay, so thank you everyone for attending, and we'll be back again this same time tomorrow with a new topic, that is EDA and pre-processing. Yeah, so friends, thank you everyone again. Bye.